So by now you all should have picked up a new calendar and a new packet. Please open up to page 1 and in your tables answer number 1. We'll pause the video and give you 2 minutes, no more, to answer number 1. Okay, so in your groups, hopefully what happened is you said something along the lines of no. Since all circles are similar, they would all have the same number of stakes regardless of what their radius is. So if we look at number 2, let me get some room here, sorry. Show where the stakes would be located using Alice's method if one set of markers were to be placed on a circle 12 meters from the center. So that's this inner radius is 12. And the second set of stakes is 18 meters from the center. So ideally we would have a piece of string that I could show you with, it's going to be pretty hard to do making a video, but if I put my first stake, let's say here, and I find a length of 12 around the circle, let's say the next one is about here. So what I'm saying is this length is 12 meters. And then if we go another 12 meters, and another 12 meters, and another 12 meters, and another 12 meters. So I tried to make that so all of these arc lengths look like they are 12. Then we can do the same thing with the outside circle at 18. So let's say here's our starting spot. And we'll take 18 meters, be about here, and then go another 18, and then another 18, and then another 18, and another 18. So that's 18, 18. We get the same number of stakes on the inner circle and the outer circle, just like we said to the answer in number 1. Okay, turn the page. After looking at the model, Veronica says they need to have more stakes if they intend to be specific, if they intend to be specific with the location of the artifacts. Since most archaeological sites use a grid to mark off sections, Veronica suggests evenly placing 8 stakes around the circle and using the coordinate grid to label those points. Alice wants to make sure that they record the distance around the circle to each stake. The central tower is located at the origin, and the first set of 8 stakes for the inner and outer circle is placed at 12-0 and 18-0. And you can see that labeled on our picture here. Our job is to determine the x and y coordinates for the remaining stakes on the circle, as well as the arc length from the points 12-0 or 18-0, depending on the inner or outer circle. We're going to keep track of the methods. So we'll write down the methods we use because we're going to need them on the next page again. Okay. If we want 8 stakes around, and let's just start with the inner circle. We can do 1 at each quadrant. So that's 1 at the 12-0, another one at 0-12, another one over here at -12-0, and a fourth one down at the bottom. So if we want 8, we can go halfway in between to get our other 4 locations. So now we have 8 stakes. We can do the same thing on the outer circle. Okay. Because this inner halfway stake is half of that quadrant, we know that this central angle is 45 degrees. We also know the radius is 12, And we need the x coordinate and the y coordinate of our point. So we're going to pause the video here for you and your groups to figure out the x and y coordinate. Okay, so what you should have done is that the sine of 45 equals y over 12. And when you multiply 12 to both sides, we get y is 8.5. So then if we do cosine of 45 is x over 12. Multiply 12 on both sides, we get x is 8.5. We can do the same thing for the outer circle, but now the radius is 18. So we'll pause the video, find out that outer stake length, the location of the outer stake. We can call the horizontal x and the vertical y again. Okay, so you should have done sine of 45 equals y over 18. And when you solved for y, you got 12.7. And cosine of 45 is x over 18. And you would get x is 12.7. So if we label those coordinates, this point is at 12.7, comma 12.7. And the inner circle one is at 8.5, 8.5. Okay, so moving around our circle, because we are well aware of the angles of rotation and reference angles at this point, I can find, well, this is over 0 and up 18, I can find the other halfway point values by using the values we have already found. For this bottom left point, both x and y are going to be negative. And for this last point, the x will be positive and the y will be negative. The same goes for all the inner points with the smaller radius over 0 and up 12, negative 8.5, positive 8.5, negative 12, 0, both negatives, and just the y negative. And we're going to use all this information on the next page when we start to find the arc length to answer the rest of that question. So Javier suggests that they record the location for each stake around the center in a table. So Veronica says it's also interesting to do the ratios, so we have to fill in some information here. All right, for stake 1, we're going to call that the stake on the far right, and that was 12, 0. And then the next one was 8.5, 8.5, and then 0, 12. So fill all these in. You pause, we're going to pause the video for you to fill them in. When you start again, mine will all be filled in. Okay, so check to make sure all of your points match what we had from the first page before. And now to find the distance along a circular path, if we think of our archaeological plot there, we split it into those 8 stakes. So what we're looking for is this arc length, which is a fraction of the circumference. So as a refresher, circumference of a circle is 2 pi r. So if we're at our first stake, we have gone no distance. We will write that as 0. But now to the second stake, we have a fraction of the circumference. So let's see how many pieces we've broken our circumference into. So you got 1, 2, 3, 4, 5, 6, 7, 8 pieces. So if we do 2 pi r divided by 8, so 2 pi r divided by 8, each piece is going to be 3 pi in length. So 2 pieces is 6 pi. Three pieces is 9 pi. 4 pieces, 5 pieces, 16 pieces. Oh, not 16, Miss Weiss. 1 piece, 2 piece, 3, 4, 5, 6, and then last 21 pi, and if we go all the way around, we get to that circumference of 24 pi. We're going to pause the video here for you to do the same thing with the 18 meters. Figure out what is the circumference of the whole circle and what will each arc length be of that entire circumference. Okay, so you should have gotten that each arc length is 9 over 2 pi. So when you add another one, that's 9 pi. Now it got tricky. Now we're going to add another one. So 9 plus 9 over 2 is 27. Oops. Over 2 pi. And then the next one would be 18 pi. And then we have to do 18 pi plus another 9 over 2. If the fractions are bothering you, write them out. You need a common denominator. We already did this unit. We get 45 pi over 2. And then the next one would be 27 pi. And if you do 27 plus 9 over 2, make a common denominator, add them together, and you would get 63 over 2 pi. And then lastly, if we went all the way around, that should be your circumference of 36 pi. Okay, so here's the part that we're working up to. We want the ratio of the arc length to the radius. So I'm going to do we'll do the first 3 boxes together, and then you are going to finish them as a table. Then we will unpause the video for you to see your answers. So the first one, the distance is 0 over the radius of 12. That is 0. That one's not bad. Now if we do 3 pi, so that's going to be 3 pi over 12. That reduces to pi over 4. Then we'll do 6 pi over 12. And that reduces to pi over 2. So what I would like you to do in your tables is just finish this column, and then we'll check our answers together. So your reduced answers should be the answers that I'm writing in the box. Okay, it's a little bit harder now that when we do the outer circle because we have some of these fractions. Let me give myself some space. Okay, so 0 over 18 is still 0. Now we're going to do 9 over 2 pi times 18. I'm sorry, divided by 18. So instead of dividing by 18, we're going to multiply by 1 over 18. So 9 and 18 can reduce, and you are left with pi over 4. The next one's going to be 9 pi over 18, and that reduces to pi over 2. Okay, so finish this column, the last 5 boxes. And your answers should reduce to the same fractions that I have, the 5 pi over 4, 3 pi over 2, and 7 pi over 4. Okay. What interesting patterns might Alice, Javier, and Veronica notice in their work and their table? We're going to pause the video here and give you 3 minutes to summarize any interesting pattern that you see in the table above. Okay, so hopefully you notice that the ratio of the arc length to the radius is the same for each angle of rotation around the circle that we did for the stakes. So for example, when we went 45 degrees, this ratio of pi over 4 is the same even for the bigger circle. And let's see, over here at stake 5, the pi and the pi were the same. So if we break that down, 45 degrees is equal to pi over 4. Oop. We can also say that 180 degrees equals pi. And these pi units are called radians. A radian is the ratio of the arc length to the radius. This value of 180 degrees equals pi radians is something that you will have to get stuck in your brain. We are going to use it over and over and over and over again. Okay, if you are interested in seeing more information about radians or seeing some visuals and some other ways to summarize what a radian is, you can visit this website, mathisfun.com/geometry/radians. They have some really good, helpful information to help solidify what a radian is. Okay, so your homework is page 5 and 6 in the packet. You should use your calculator. It says it right here. Make sure to read everything very, very carefully. And you have the remaining part of the class period to work on your homework.